Welcome to the SigmaJunmaSize Introductory Example e-learning module.
Okay, I'd like to welcome everybody to the Sigma Sizing web class using SigmaJunmaSize. My name is Paul Zajac. Today's agenda will be to just do a demonstration of SigmaJunmaSize. This is not intended to be training a servo sizing theory. We do have an e-learning module on sizing theory, and it's available on our website. We're going to go through two examples. We're going to do a ball screw example and a roll feeder. Our new SigmaJunmaSize software is available on our website. Just do a search under SigmaJunmaSize. It will come up with this first screen. Installation is 11 megs. And if you have any problems installing the software, please let me or anybody at Yaskawa know. We haven't had any problems thus far. So, the features of SigmaJunmaSize is that we can size all Sigma series motors. This includes Sigma 5, Sigma 3, Sigma 2, and the older Sigma and also Junma series. This also includes our direct drive motors and our linear motors. This sizing software set up with a wizard allows us to select the machine configuration by different figures. There's about 7 different setups available. And then all the machine information is clearly illustrated. I'll show this later. This does have a built-in inertia calculator. We can calculate by mass or density. And then all the machine data and velocity profiles can be loaded from previously saved files. So if you have a similar application, you can just open up that application and just load specific parts of it. This software will also calculate the regenerative energy. We can also select the motor options, select an applicable servo amp and option module, and all this information can be shared with others. The nice thing about selecting the motor and the amp options is that it would automatically create a quotation request with the full part numbers. So I'd like to get right into an example. And the first example will be the ball screw example. Some of you may have seen this slide. It is on the other sizing e-learning module. I did make a couple changes. Basically, the application involves a ball screw. The lead is 1 revolution per inch, and the manufacturer lists the coefficient of friction as 0.1 and the system as 93% efficient. We're going to be moving a 5,000 pound payload. And the ball screw is 4 feet long, 1.5 inch diameter, and made of steel. And that is coupled to the motor with a 3 inch long by 3 inch OD coupling. And the move requirements are 44 inch move in 12 seconds, and the top speed that we want to achieve is 250 inches per minute. We're going to assume the same XL and decel time. There is an option to add a 5-to-1 gearbox, but we want to evaluate if that's necessary. I'm going to launch right into the software. Okay, this will be the first screen that you will see when you open up the SigmaJunmaSize. And the best thing to do the first time you ever open the software is to go right into the user info registration and enter in all your information. The nice feature about this is that it will automatically, well, you only have to do it once, and then it will automatically populate other screens such as your sizing results printout, which you can share with your customer, and also a quotation request. To get started, we'll go to the wizard sizing. And the first screen we get is the unit screen. You have a choice of setting up all units as SI or US. We're going to use US, but we're going to make a few adjustments to the default choices. We're going to put length to inches, speed to inches per minute. I'm going to change the acceleration to also inches per minute. I want to make a note that the efficiency is set up as no units. So basically we're going to set up, so efficiency will be set as from 0 to 1. You also have the option of setting as percentage. I'll leave it as no units. I'm going to leave all the other units the same, as is. Go on to the next screen. Did want to point out this is the only screen where you will be able to make changes in units. So if you decide later that you want to change a unit, you'll have to come back and make that change. It will not convert the data that you already have entered, so it will just change the unit. Here's a note, what I just said. For this application, we are going to choose the ball screw. We do have other choices of ball screw horizontal or vertical. There's also a timing belt, rack and pinion. And then along the bottom here is roll feeder, which we're going to do later, and also a rotor, a rotation table. So this would probably be used when sizing direct drive motors. There's also an option to size a linear motor. So we'll stay with ball screw horizontal. As you can see here, we have an illustration of a ball screw machine. And by each component, there's a number which relates to the input, the data that we'll have to enter. So we can start off by mass of load. For this application, it was 5,000 pounds. The mass of the table was not given, so we'll assume that it was included with the mass of load. So I'm going to enter a 0. Each field must have some value entered. The thrust force was 0. Coefficient of friction for the ball screw was 0.1. Gear ratio, there was first we're going to start off by using no gearbox, so I'm going to set the gear ratio to 1. We do have a coupling. We can either enter the coupling inertia, if we know it, into this field here, or select this icon, which will switch us to the inertia calculation screen. There's a bunch of different options available, so you want to select the part that's applicable to this. So for the coupling, it's a hollow cylinder. You can also size by mass. We can calculate the inertia entering a mass and the diameter. But for this application, we're going to stick with entering in the density. Now the length of the coupling was 3 inches. The OD was 3 inches. The ID was 1.5. Material was aluminum. We have 1 coupling. I'm going to press calculate. It's going to calculate the inertia for me. And once I hit OK, it's going to transfer that information to this machine information screen. The gear efficiency, we're going to assume it was 1. Now in the ball screw section, we're going to enter ball screw information. Pitch is 0.5 inches per rev. The diameter, 1.5. Length of, I think it was given as 4 feet, so we'll enter 48 inches. And the density was steel. We can also enter, if you know the density, you can also enter it yourself. Because the only choices right now are aluminum or iron, or steel. And the efficiency, total efficiency, here's where we'll enter the 0.93. A couple other comments about this screen. If you have questions on what formulas are going to be used for this sizing, you can select the help icon, and it will take you on a help of this screen. And it will also show you all the formulas used. And then towards the bottom, there's going to be each machine type configuration will show the applicable data fields and the equations used for inertia and torque calculations. One other thing I want to point out, the illustration does indicate a positive direction for velocity and also a positive and negative direction for thrust force. So please keep that in mind when sizing your applications. And then also this icon here is where you will be able to load in previously saved machine information from other sizing files. I'm going to move on to the next screen. Next screen is where we're going to enter the velocity information. I'm going to go back to the presentation. Now, the move requirements for this application was a 44-inch move in 12 seconds max and a top speed of 250 inches per minute. We're going to assume a trapezoidal move profile with XL time equal to decel time. The basic equation is going to be the distance is equal to the area under the curve. So when I solve for the time of acceleration, I'm going to get 1.44 seconds. And my traverse time is going to equal 9.12 seconds. I'm going to use this information to input into the velocity screen. Go back to the sizing, and enter this information. 1.44 seconds, accel. 9.12 traverse. 1.44 second decel. My peak speed is 250 inches per minute, and my cycle time is 12 seconds. Hit apply. The graph adjusts to this new velocity profile. If I wanted to add dwell, I would basically add some more time to the total cycle time. This is one option of entering your velocity profile. The other is this detailed section where you would enter in the endpoints of each move segment. So you'll have to do a little more calculations to figure out all these different values. I'm going to stick to the minimum. Apply. Also, one thing to note, you can also load in previously saved velocity profiles using this icon. Next screen is our operating conditions. This is where we can basically filter out what we want to size. Default is going to be Sigma 5 and Junma. Since this is called SigmaJunmaSize, I'm going to unhighlight Junma. I only want to size for Sigma 5. You can also filter out which specific motors by selecting this Models button. You can go ahead and select which motor you want to size for. When it's white, that means you only going to size for that particular model. If nothing is selected, then all series will be candidates for the sizing. I'm not going to make any changes. Hit OK. Also, we have a choice of selecting encoder type. It says absolute, which means it's not on, so it's gonna size for an incremental encoder. If I want to size it with an absolute, then I need to select it. Same thing goes with holding break. We also have an option to choose which standard. There's an option for or, and then if none is selected, then they'll all be candidates. They won't take the standard as a criteria. I'll choose a different IP rating of the motor, oil seal. We can also filter out with the type of servo amplifiers. Now for Sigma 5, we only have one type of amplifier available. If I was to choose Sigma 2, and go back to the servo amp models, then there'll be other choices available. You can also select by different input power. Again, standard for the amplifier, ULCE or TUV, and also by control method. At the minimum, what I do is I just select the different Sigma series and leave everything else as is. By not making any selections, pretty much leaves everything available as candidates for the sizing selection. So moving on. So now the sizing software is calculating which motors are applicable to the application. And it's only going to show those motors that are going to work for this application. Now there are some red flags, and the red flags are basically warnings. For this example, the SGM-GV09, it is flagging that the inertia ratio will be 8.5 to 1. Now the allowable inertia ratio for the SGM-GV motors is 5 to 1. So we would recommend choosing a motor that would be under 5 to 1, which would be the SGM-GV-20. There's also red flags for rated speed. If the application speed is above the rated speed, it's kind of giving you a warning. Doesn't mean that the motor won't work. Just be careful of it. Also in this screen, you can see by selecting this formula tab, this will show you all the sizing results, including your input, your velocity profile, motor specs, all the inertia results, torque results, and also for those familiar with SigmaSize, we do show each move segment's torque. So basically the torque required in the accel portion of the move is 5.361 Newton meters, The traverse, it was 4.83, and the decel was 4.3. It's kind of a nice option of SigmaSize, and it is available with SigmaJunmaSize. At this point, I want to point out that the actual application requirements are listed on this right column. So it lists the peak speed, total inertia, and also the peak torque and the effective torque, which is the RMS torque. But I want to go back and look at the option of adding a 5-to-1 gear head. So I'm just going to go back to that screen. So now that I'm in the machine information screen, I want to go in and enter this 5-to-1 gearbox. I'm going to do that by selecting this icon, the deceleration ratio icon, similar to the transmission screen of SigmaSize. Here I'm going to enter in a gearbox. I have options of also adding a pulley or a gear. Enter in the gear ratio of 5-to-1. The efficiency was 85%, so I'm going to enter 0.85. The inertia was 0.0016 inch-pound second squared. It doesn't show the units here, so you got to remember what you selected in the first unit screen. Hit calculate. Hit OK. Now one thing that this kind of wiped out was my coupling inertia, so I need to go back to that transmission screen and enter in my coupling inertia A into this field here. And there's also this inertia calculator button. All the previous information is still stored there. So I can go ahead and hit calculate. Okay. I have to update the screen, so I got to press calculate on this screen. Okay. And so now I have counted for my gearbox and my coupling inertia. Next. Velocity did not change. So I have some other choices now. Some smaller SGM JV motors came up and the AV motors. I'm going to go ahead and select the SGM JV 08. Next. My next screen is where I can select my amplifier. My choices right now for Sigma 5 are the analog version or the Mechatronic version. I'm going to stay with the analog version. This screen will also tell me if any, will tell me what the regenerative energy is for the application and if I need any external resistance. Right now it's showing me that regen energy is 0. And of course, no external resistance is required. The option selection screen allows us to select different options for the motor and the amplifier. The encoder, since we had pre-selected this, it only gives us the option of absolute encoder. If I do want the incremental, I can always go back and choose incremental encoder. A couple options for the shaft. I'll keep that straight, no key. And the brake, there's only one option because I had pre-selected this in the previous screen. Right now for the Sigma 5 amplifiers, there are no options. As options become available, we will be updating this to SigmaJunmaSize. Move on. And the next screen allows me to save the information. So I can enter in name. You can enter in any information you like. If I just hit save, then it's going to save to like a kind of a hidden file that only SigmaJunmaSize will be able to open up. You will not be able to share that. If you select text, then it's going to save both as a hidden file and then also as an option to save to your hard drive. So I'm going to go ahead and hit save. So it's going to save it like internally into the sizing software and also give me the option or allow me to save it into my hard drive. And these SSD files are what you can share with your customers. Another feature here is this results tab. This allows you to print out your sizing results. As you can see here, it already has all the user information entered. You can enter in your customer information and any other data. Hit OK. And I already have this printed out. You can print to your printer as a PDF. Basically, it looks like this. This was my note from earlier. I put it in ball screw example. We'll show you the motor type, amplifier type, and it will go ahead and show you like the machine information you used. So the velocity profile and all the calculations. And the specs of the amp. And the formulas used to calculate those results. I'm going to move on to the next example, but before I do that, I want to show you the option to automatically do a request for quotation. It's basically going to open up all the sizing files I had saved internally into the software. This last example was this ball screw example, so I'll select that and choose quantity. And here I want to enter the quantity that I want quoted. So I'll say, like 1,000 pieces. Hit OK. And this invoice tab is where you can enter in the where you want this quotation sent to, or this request for quotation sent to. So you can enter in the data fields here. I'll just put in Yaskawa. And it will kind of set up or print out a quotation request. This is what it looks like. There's some basic feature. Okay, another question. Could you clarify more clearly the white and gray button on selection of amplifiers and motor types? When the button is gray, it means that that choice is not selected. When it is white, that means we are choosing that option. So for example, if I want to choose for the series Sigma 5 and Sigma 3, I will want both of those highlighted white. For the motor models, right now everything's gray, so that nothing is selected. But I could go in and select this specific motor model. So if I'd only want to size SGM-GV, then I highlight that. I can also go in to the other series. Since I have Sigma 3 series now available, I can just choose what Sigma 3, Sigma 2 series I want. Once I make a selection, then only that motor type will be used. If I don't make any selections, then it's going to use all the motors. Same thing goes with the servo amp models. There's not too many different options for Sigma 5 and Sigma 3, so basically I would just leave it as is, or you can select both of them, and it will size in SGDV and SGDS. This does not size Legend amplifiers. A follow-up question on this white and gray buttons is what is the half and half on UL-CE? Let me just explain that. Basically, we have the option if in the standard section for the motor and the amplifiers. We can filter out if we need like UL or CE or TUV, or if we need all of them, if we need UL and CE. So basically, if the half gray, half white means or, so basically if it's UL or not, and this would mean UL or CE. If I require UL, then it would be, then I would have to select it. I need UL. This would be I need UL or CE. If I needed both, then I would select I need UL and CE. There's a question, when requesting a quote, does it automatically include cables and other accessories? At this time, no. It only does, this sizing software will only select your amp and your motor. It will also select amplifier option cards. So for Sigma 2 series, there's some option cards available. It would also list the option card. Okay, I'd like to move on and show you, there was a question on how to open up save files. Basically, the button here, the data load delete. You can either open the file from the internal list. So for this last example, we had ball screw and hit load. Done. Or open it from the file from your hard drive. So if somebody sends you a sizing file and you want to open it, it has to be this SSD file. I believe the last one we saved was, no, pause screw. Open. Back. Just want to show you that all the information is still saved, including the units, the machine type. It does store all the information in this machine screen, but not necessarily the information that we had entered in the transmission screen. Or the inertia calculation screen. If I had been doing another sizing and the values in here were different, it would probably be showing it would show the last saved results or the last open results that I have or data that I had to put into the transmission screen. So the only saved information is going to be what's shown in the machine information screen. The nice thing when open up a saved velocity profile is that it will also convert all the information that you had put in the minimum screen into the detailed screen. It doesn't do that until after you've saved the file. Just keep note of that. I would like to go back and show you how to open just the machine information. It will only open up those files that you have saved internally. And every time you save it, it's always going to save a copy into this like hidden file. So yesterday I added a 5:1, or I saved a 5:1. Hit OK. And it loaded up a gear ratio of 5:1. So it made the changes here. I want to go to the next example. It's going to be it's a nip roll example. There are basically two rolls that are 3-inch OD, 10-inch long, made of aluminum. We're going to assume the belt is negligible weight. There is a pulley ratio of 1:1. Each pulley is 3.5-inch OD, 1 inch thick and made of steel. The web's going to pull back with a force of 20 pounds. One machine cycle consists of 15-inch move material, and it will stop to allow the material to be perforated. The index occurs at 120 cycles per minute with a 50% duty cycle. Machine efficiency is 85%. We'll go ahead and calculate the move profile. 120 cycles a minute with a 50% duty cycle results in a 0.5 seconds per cycle. At 50% duty cycle, this is going to take my total move time to 0.25 seconds, my dwell time to also 0.25. So assuming a triangular move profile and simplifying it where the accel time and decel time are equal, and the basic equation is going to be the distance under the curve. My velocity will result in 120 inches per second. So let's go back to the SigmaJunmaSize. I'll start off by hitting wizard sizing. Change my units. Now we're working in inches per second, so I'm going to go ahead and change my speed and acceleration. Leave everything as is. I'm going to select my new machine type, which will be the roll feeder. Next. We'll go ahead and enter in the machine data. So for number 1, tension. Tension was 20 pounds of force, and it was going to move, but it was going to hold back the feed. So I'm going to enter in minus 20 pounds of force. My press force wasn't given, so I will say 0. Coefficient of friction, you must enter a value greater than 0. So I will enter in just leave it 0.1. Now it's saving some of the previously inputted information. To avoid this, you can just restart SigmaJunmaSize, or just go ahead and just change it. So I'm going to change the gear ratio to 1. A couple options of entering the pulley inertia. I can go into this transmission screen and select pulley. Ratio is 1:1. Efficiency 1. Inertia. I can hit the inertia calculator icon and enter in the information here. And the length was 1. Diameter was 3.5. It was, no ID was given. Change the type to a solid cylinder. Steel pulleys. Quantity 2. Hit calculate. Hit OK. I'm going to remove this coupling inertia. Change that to 0. Calculate. So everything updates. Hit OK. I want to point out this coupling B is the coupling that will be between the transmission and the load. This application, we don't have a coupling there. Just want to make note of that. I'm going to enter in the driving, number 6, the driving roller inertia. It's 10 inches. Diameter 3. They were aluminum. Quantity 1. Calculate. Okay. That's the driving roller inertia. It's actually the same for the driven roller inertia. This icon. All the data is still the same. I calculate. Okay. Driving roller diameter was 3 inches. And my efficiency was 0.85. Let me go back. There's a question. It says if, in your example, the pulleys are 1-to-1, but if they're not 1-to-1, how would you change this? I can show you that. So let's say we had a 2-to-1 pulley. A couple ways of doing it. I would set up one pulley here. In gear 2, I would set up the next pulley. On the motor side, I would enter this one as 2-to-1 and leave the second pulley as 1-to-1. So if it was 2-to-1, this is one way of setting it up, where you would enter in the first, I would enter in the motor pulley, gear 1, the load pulley, and in gear 2. And the reason that I put velocity ratio of 1-to-1 for the second pulley is if I put 2-to-1, it's going to compound those and assume that I have a 4-to-1 gear ratio. And what this does is it's going to take gear 2 and reflect it back to the motor, take into account gear 1's velocity ratio. So this is one way of doing it. Another way of doing this sizing is to actually just set it up. I'm going to enter in a pulley of 2-to-1 and changing this inertia to 0 and entering in, if I only had the 2-to-1, then I would enter in one pulley as my coupling A inertia. And then my other pulley as my coupling B inertia. Calculate. So the actual results are the same. The final inertia is the same. I'm going to go ahead and leave in this pulley inertia of 2-to-1, or this configuration with the 2-to-1 pulleys. Hit OK. So now I have the new information: gear ratio of 2, the new gear inertia, and everything else remained the same. So I'll go ahead and move on to the next screen. This was a triangular move profile. Move time of accel was 0.125. Regular operation was 0. Decel was 0.125. Peak speed of 120 inches per second. And my total move time will include my dwell time, so it's going to be 0.5. So it's going to show you, the graph is going to show you what the actual move is going to look like. Go ahead and hit next. This time, actually I'm going to leave the absolute encoder option on. the size for Sigma 5 motors. Leave everything else as is. Move on. Okay, so it's showing me all the applicable motors for this application. It is flagging my speed because my required peak speed is 1500 RPM. The rated speed is 1500. Now these motors are capable of a maximum speed of 3000, so these motors will work. It's just that the actual top speed of the application is above the rated speed. So I'll go ahead and choose SGM GV09. Next. This is actually explaining what the warning is. Input velocity became more than motor's rated rotation speed. Be careful in using under this condition. It's gonna show me the applicable servo amplifiers. Go ahead and stick with the analog version, Sigma 5. Once again, I can change different options. I'm restricted to only the absolute because that's what I had selected beforehand. I can change the different shaft options. I have one option for the brake, no options for the amp. Next. And puts me to the save screen. So that's basically it for my demonstration. This concludes our webinar on SigmaJunmaSize. So thank you.